Good evening, good afternoon, good morning, whichever time it is that you're watching this. Hope you're having a great day. Today we're going to talk about applications of direct and inverse variation. How to apply your direct or your inverse variation equation when it deals with word problems or daily, everyday life. When do we use direct? Well, in situations where one of the variables is going one direction or is going up, the other variable is also going the same direction or going up. When do we use inverse? Well, in situations where one variable is going one way and the other variable is going the opposite direction. Or one's going that way and the other one's going that way. So, again, this is video 12D. I'm looking at pages 5 and 6. I'm only going to do one example of each. First one for direct variation. This is number 1. Now, understand that again, direct variation, we have y over x, y over x. Okay, so it's the same concept when we found the constants or find the missing values that we're going to be using for this word problem. It says, the sales at a baseball game vary directly. This is how you know, excuse me, I guess my board is a little bit off, as you can see, but this is how you know which one you're going to use. With the number of people attending, if the sales for a game are 12,000 when 800 people attend, determine how many people attended the sales for a game are 15,000. So in this case, we're going to set up 12,000 over 800 equals 15,000 over x. So we're going to cross multiply. You have 800 times 15,000, and that gives you 12 million. And 12,000 times x gives you 12,000x. And you're going to divide 12,000 on both sides, and you get x equals 1,000 people. So if the game was $15,000 in sales, that means about 1,000 people attended the game. Now you can use the same concept for problems 2, 3, and 4, but be careful with 5 and 6. They're only asking for the constant. So if you want to pause the video now and work on page 5, you may do so. Now, if you've done page 5, let's do page 6. Number 7. It says inverse variation application. So in this case, we're going to apply the inverse variation. And if you remember, we did the multiplying of x times y equals the same thing as x times y. And that's how we set it up. Time traveling varies inversely. I'm doing number 7. This is page 6. It varies inversely. Again, this is how you know which one you're going to use. Make sure you read the question. With the average speed. If a train travels between two cities in 3 hours at an average speed of 65 miles per hour, how long would it take an average speed of 78 miles per hour? Okay, so let's set it up. 3 times 65 equals 78 times, I believe it is y. So now let's multiply. 3 times 65 is 195. And you have 78 times y is 78y. Divide 78 to both sides, and you get y equals 2.5. Which means if the train goes at an average speed of 78 miles per hour, it only takes 2.5 hours to get between the two cities. Now, you can solve 8, 9, and 10 in the same concept, same way as this. Number 11 and 12, though, they're only asking to find the constant of variation. So be careful when you do numbers 11 and 12. Good luck on finishing page 6. Hopefully this has helped you out. Have a great day.